All right, let's dive right into this explainer. Welcome to the Bombardier Q400 Flight Simulator Weather Survival Guide. Today, we're breaking down some seriously extreme aviation weather hazards, and more importantly, we're going to cover the exact procedures you need to effortlessly memorize to keep the aircraft flying safely. Whether you're a seasoned aviation geek or a pilot in training, surviving these environments is all about rapid recall, so we're going to use some highly specific memory tricks that tie directly to your simulator controls. So, here's our flight plan for this explainer. We're going to tackle these 5 sections sequentially: wind shear rules and responses, jet streams and volcanic ash, navigating heavy precipitation, sandstorms and mountain waves, and finally, significant temperature inversions. Okay, Section 1, wind shear rules and responses. We're starting this off in the absolute most critical phase of flight, below 500 feet. Down there, abrupt changes in wind speed or direction leave you basically zero time to recover. To effortlessly memorize the 6 signs of wind shear, I want you to use a trick we call the cockpit scan. You just link the indicators to what your hands feel and what your eyes see on the Q400 instruments. Think about it. If your hands are suddenly fighting unusual control forces on the yoke, or you're having to make crazy thrust lever adjustments, you're in it. Then shift to your eyes. Look for significant airspeed changes, totally unusual vertical speed changes, unexpected pitch shifts, or a massive displacement from your glide slope. Hands, then eyes. It's that simple. Now, actually dealing with wind shear requires a really strict 3-step sequence: avoidance, prevention, and recovery. Avoidance is obvious, right? Actively look for clues like pilot reports or thunderstorms. But if you absolutely must fly, prevention requires some counterintuitive actions. You have to use maximum takeoff thrust instead of reduced thrust. Use the longest suitable runway. And here's a big one: do not use the flight director. Your attitude indicator is your primary reference now. You'll also want to use the minimum landing flat position. If all that fails and you're on final approach below 500 feet, step 3 is recovery. You immediately execute the wind shear escape maneuver exactly as it's written in your Q400 manuals. No hesitation. So what does marginal flight path control actually look like below 500 feet? Use the rule of 5s and 15s trick to spot it instantly. Just look for these 5 things: a 15-knot change in indicated airspeed, a 500 foot per minute vertical speed deviation, a 5-degree change in pitch, a 1-dot displacement on the glide slope, and an unusual thrust lever position. See that? 5 total items, all anchored by the numbers 5 and 15. Memorize that, and you'll catch a marginal flight path in a heartbeat. Section 2, jet streams and volcanic ash. Let's see how the hazards completely change as we climb up near the tropopause. Up here, you're going to find jet streams. These are narrow bands packing staggering winds, up to 300 knots, and they generate dangerous clear air turbulence, or CAT. To effortlessly memorize where this invisible turbulence hides, use this phrase when you're looking downwind. Left is north, right is south. Basically, the turbulent region sits to the left of the jet core in the northern hemisphere and to the right in the southern hemisphere. Escaping that clear air turbulence means taking a few very precise steps. First things first, reduce your airspeed to minimize the acceleration forces slamming into the aircraft. Now, if you're flying parallel to the jet stream, change your altitude by up to 1,000 feet. If you're perpendicular, change it by exactly 1,000 feet. Specifically, downward if going warm to cold, and upward if going cold to warm. But listen, here is the real lifesaver trick. If the outside temperature is actively changing, stay on your course. A changing temperature means you're already crossing the CAT boundary, and you'll be out of it soon. Only vary your course if the temperature is totally constant. Also, up at this altitude, you might stumble into volcanic ash. This stuff causes catastrophic erosion of your engine's internal components incredibly fast. And the terrifying part? The Q400 weather radar is literally blind to ash. It cannot see it. So, to detect it during the night or in instrument conditions, you have to use the SSM trick. S, smoke or dust visibly appearing in the cockpit. S, smell, a super acrid odor, kind of like electrical smoke. M, multiple engine malfunctions. We're talking stalls, spiking exhaust gas temperatures, or outright flameouts. Burn SSM into your brain to save your engines. Section 3, navigating heavy precipitation. Moving along, let's talk about the intense reduced visibility and severe icing risks that come with heavy precipitation. You know, precipitation isn't just about a bumpy, uncomfortable ride. It is a massive engine hazard. Hail can produce jagged ice up to 4 inches thick, and you can hit it anywhere from 10,000 all the way up to 45,000 feet. Just like volcanic ash, airborne radar cannot reliably identify hail. Also, do not underestimate heavy rain. Severe rain ingestion can cause such massive engine power losses that it's perfectly sufficient to cause flameouts on your Q400. Now, to effortlessly memorize the difference between the two major icing hazards, freezing rain and sleet, you just contrast them directly. Freezing rain is made of supercooled drops that instantly freeze the second they touch your cold aircraft. It forms this terrifyingly slick, thin, and almost invisible film. Sleet, on the other hand, is frozen raindrops that actually bounce on impact. Sleet still makes your surfaces slick, sure, but it is easily visible to you and the crew, unlike that silent killer, freezing rain. And as you progress even further away from a warm front, surface temperatures drop even more. That's when that bouncing sleet finally changes over into snowflakes, which are just aggregates of ice crystals collecting as they fall. That pretty much completes our sliding temperature scale of precipitation hazards. Section 4. Sandstorms and mountain waves. Next up, we leave the moisture behind and dive into abrasive terrain hazards that demand strict avoidance and really specific flight maneuvers. First up are sandstorms. Honestly, the rule here is black and white. You absolutely must avoid flying in active sandstorms whenever possible. The abrasive action of millions of sand particles acts like a giant sandblaster in the sky. It will rapidly destroy the visibility of the Q400's windscreen, completely strip your aerodynamic leading edges, and totally ruin your engine compressor blades. Just stay away. But what about when you're crossing mountain ranges? You're going to face massive atmospheric displacements. To survive this, I want you to use the lee is low trick, along with this simple rhyme. Upwind is uplifting, leeward is a letdown. When you approach a mountain from the upwind side, you'll generally ride a nice, smooth updraft. But approaching from the leeward side basically guarantees dangerous downdrafts that can easily exceed the Q400's climb capability. Never, ever expect an updraft from the leeward side. Always give yourself an extra 1,000 feet or so of altitude just to be safe. That leeward side is also home to rotor turbulences. These are incredibly strong vertical and horizontal wind shears. And the danger zone is surprisingly vast. Secondary rotors can actually form up to 100 nautical miles away from the lee side of the mountain. If you look out and see those smooth, lens-shaped lenticular clouds, consider that your glaring visual warning that mountain waves are actively rolling through the atmosphere. Okay, but what if you do get caught in this severe mountain wave turbulence? You have to execute this exact sequence to prevent serious structural damage. First, simultaneously pull back your power and adjust your pitch until the aircraft approaches maneuvering speed. Second, fine-tune your power and trim to perfectly lock in and maintain that speed. And third, turn and fly away from the turbulent area. It's a rhythm. Power, pitch, trim, escape. Section 5. Significant temperature inversions. For our final section, we're looking at how rapid temperature changes near the ground cause immediate performance loss. Inversions literally flip the standard atmosphere upside down. Instead of getting colder, the temperature actually rises as you climb. For your engines, this is a big deal. A sudden temperature rise directly causes a nasty decrease in engine power. Because of this, anytime an inversion is known or forecasted, you have to apply the performance limit corrections found in your aircraft operating manual. You're usually going to find these inversions alongside strong, low-altitude jet winds near the ground at night during the spring and summer, all thanks to rapid radiation cooling. Let's look at how this builds into coastal hazards. You need to memorize this day and night contrast. During the day, you get a sea breeze. The land heats up super fast under the sun, pulling in cold air from the sea. It's powerful. We're talking up to 15 knots, pushing 50 kilometers inland. At night, the whole thing flips into a land breeze. The land cools rapidly because of that radiation cooling we just talked about. But since the temperature difference at night is much smaller, the land breeze is noticeably weaker than the daytime sea breeze. Now, what makes this a true nightmare is the combo effect. Normally, these coastal breezes only cause moderate wind shear. No big deal. But if a microburst hits at the exact same time, the phenomena amplify each other, creating incredibly dangerous, violent wind shear. You have to be hyper aware of this on summer flights, especially to island airfields where the runways sit right on the shore. A prime example to keep in your memory bank is Port Blair. If you're flying into a coastal airfield in the dead of summer, you should always be anticipating that microburst breeze combo. By anchoring these memory tricks, from the cockpit scan and the rule of 5s and 15s, to SSM and Lee's Low, directly to your Q400 simulator, you now hold the keys to effortless recall. You've got the knowledge to avoid, prevent, and recover from the most extreme atmospheric hazards out there. But the real question I want to leave you with today is this. Have you successfully linked these procedures to your muscle memory, and are you truly ready to apply them when the real sky turns against you? Thanks for joining me on this explainer. Keep studying those manuals and fly safe.